Kaylin? No Kaylin. All right, oh, there's Kaylin. Okay. Good, everyone is here. Good morning, everybody. Hello. Change of plans for today. Well, maybe to you it won't seem like a change of plans, but I recently changed my plans depending on how actively you study the master schedule. You may have seen that I've now stretched out the section 5.3. Which one are we in? 5.3, yeah. To fill the whole week instead of going on to 5.4. So I know you already did the notes for 5.4 over the weekend, and you're so disappointed that you're going to have to save that knowledge for next week, right? You're so disappointed that we're just going to be practicing the same old thing today that we were already working on Monday because it was so easy and boring. It's going to get tedious now, right? That's exactly what you're thinking. That's probably not what you're thinking. No, this stuff is not easy. That's a good thing, okay? We don't want to just be doing the easy stuff. That's not how you grow. So for today, I have one more example that I'd like to do, just to get into the groove of things. We're still dealing with, right, the double and half angle formulas, and are they all that different from the sum and difference formulas? Not really. The concepts are all still the same. And then next week we will continue with 5.4 with the product to sum formulas, and that'll be again a very similar process. Okay, so I want you to, with this example that we go through today, focus on the structure of the process here and what general steps am I taking. Don't focus on the specific formula that's being implemented. Right? Focus on the general steps, the problem-solving technique that I am using here, because it's going to apply to all three of these sections in general. Right? Back to that big idea of we have come up with all these various formulas to try to make the trig expressions easier to work with, to exploit our knowledge of the unit circle, and to make the incoming calculus applications more manageable. Okay? So keep that all in mind. So I'll do this one example here, and then I will open it up to questions from you guys. If you had any homework questions from the Monday's problem set that you would like to get into detail, I know you have the answers from the back of the book, although I give them to you in chunks, right? But you have the answers section from the textbook. It has them all there. You should be checking your answers all the time, okay? There's no excuse for turning in work with the wrong answer in the end, okay? But if you don't know how they got that answer, now's a good time to ask. All right, so without further ado, here is our example for today. If squiggle, what the heck is going on? Okay, cosecant of alpha, you got to learn your Greek letters. That is my challenge for you over the summer, okay, to get prepared for college. It's not on any high school curriculum anywhere, but it should be. We should just add it to the list of Common Core, like standards. You should graduate, you should know the Greek alphabet, okay? Capitals and lower cases. Cosecant of alpha. So our unknown angle, call it alpha. Cosecant is negative 25 over 24, and alpha is in quadrant 4 in Roman numerals. And know your Roman numerals, okay? Greek and Roman. Find then sine of half alpha, cosine of half alpha, and tangent of half alpha. Okay, how are we going to approach this? I see this problem broken into two parts. Whenever you see a if this is the case, So that means we're going to assume that's the case. They say if, it's not an if, it is. That is absolute. Here is stuff you already know. Okay? So group this, right, all of this, just kind of like annotate here, right? This is stuff we know, okay? And I can add on to that, right, our unit circle, and our formulas, right? Our algebra skills, etc. Okay? This is the particular bits that you already have for the starting stuff from the problem. And so we can take one route to go from here without even reading the rest of the questions and say, hey, how can I take this and create new stuff, right? What else could I figure out from this given information? Okay? I'm given the cosecant. Hey, I know a relationship between cosecant and sine, so if I know the cosecant, I could quickly find the sine, right? That kind of thing. And so you could start generating a new list of things that you can figure out from the given. Also, we have the second half of the question. What comes after find? Find this. This is what we're looking for. This is our target here, right? So this tells us what to look for. Okay? That's our goal. We need to find a connection between the stuff we know and this leads to this, leads to this, leads to this, leads to the stuff we're looking for. So you can take this and you can work backwards. That is the saddest looking excuse for a K I've ever seen. Okay? Instead of going, well, I know this, what could I figure out from there? You can instead work backwards, saying, hey, if I need to get sine of alpha over 2, I don't actually know what alpha is yet. So one way to work backwards is, hey, if I can find a value for alpha, I can just divide it by 2 and take the sine. That's easy. Right? Right? You've got a button on your calculator for that. Sine of known angle. What's not so easy is the unknown angle. That's what we're dealing with. Okay, so find a value for alpha. We could do that. Or notice sine of half alpha. Hey, that's a half angle formula. Ooh, maybe this means I'll need my half angle formulas, right? Or what was the other option? We could determine alpha. Right? And one of those, one or both of those, could lead a daisy chain your way back to the stuff that we know, these bits up here. Okay, so I'm going to do a bit of both. And you can kind of see both sides coming through here. You can just continue in all of one direction or all of the other. Whatever you see first, whatever makes the most sense to you, use that strategy. Okay? So let's look at the beginning. First, what we know. I know cosecant of alpha equals this over this. Hey, they gave it to us as a ratio. It's already a fraction number. That's perfect. Fractions are our friend in trigonometry. Because every trig ratio, okay, hear that term, ratio, it's a trig ratio. It's actually two sides of a right triangle. So on that path, let's draw a right triangle. Alpha is an angle in quadrant 4, so I'm going to draw a quick sketch of quadrant. Pen, please. Quadrant 4, right? That's down here. 1, 2, 3, 4. Right? And some angle in there. I really don't care what it looks like in there as long as it's in quadrant 4. And draw perpendicular to the x-axis. Right, this is our x, this is our y. So then this becomes our angle alpha. Now, what do we know about cosecant? I don't remember cosecant. That's not in SOHCAHTOA. But I know that cosecant is 1 over sine, right? Because when it comes to the secants, the cos do not go together. That was just one of those rules that it didn't work out quite as nicely sounding as you would like. So the co doesn't go with the other co. So cosecant goes with sine. I know that sine is SOHCAHTOA opposite over hypotenuse. So that means this is the reverse of that. This is hypotenuse over opposite. Okay. And so remember that was negative 25 over 24. So hypotenuse is up top, that's 25. And the opposite is 24. The fraction has to be negative. One of these needs to be negative. It should be this one because we're landing in quadrant 4, so that checks out. So now I can see this is a triangle, a right triangle. It should be like begging you, please complete me. Find the other side of this triangle, the missing link, okay? The missing side. This sounds like a Pythagorean triple. I'm pretty sure this is a Pythagorean triple, 24 and 25. Doesn't that sound familiar to you? I mean, you can go the full length, Pythagorean theorem, c squared equals a squared plus b squared, right? But let's double check. I think it's a Pythagorean triple. Never mind that I was looking up Batman costumes. Pythagorean triples, something 24, 25. Oh, there it is. There it is. You see it? 7, 24, 25. Yes. Awesome. It's going to save me a bit of time. 7. This is obviously not drawn to scale, right? 7 is really small, and then 24 would be like way down. I should draw my angle like down here. Would look a little bit better. But that doesn't matter. It doesn't say draw the angle. Nowhere in this problem did it ask you, you need to plot this angle somewhat accurately. Nope. Doesn't matter. Don't care. Not drawn to scale. But this is enough. Now I have 3 sides. If I have 3 sides of a triangle, I can write down all 3 trig ratios, right? I can write sine of alpha. I can write cosine of alpha. I can write tangent of alpha. We can do one better. We can go all 6, right? We can write cosecant, secant, okay, and cotangent, right? We could do that, yes? You can see the path forward. That's where it's going to go. And continue on from there. All right, let's take a break here. Let's run back to the other side of the problem. What are we looking for? I'm not trying to find sine of alpha. I'm trying to find the sine of alpha over 2. Well, again, I could determine alpha itself, okay, but years of textbook question answering has led me to this experience. And maybe I'll put it as like a hot tip on the side, okay? Hot tip. Keep your solution as general as possible, okay? You want to wait until the last possible moment to actually plug in a number for alpha, okay? Because as soon as you try to work out and determine exactly what alpha is, right? This ends up being, this is problem 4a. And then problem 4b comes along and it says, well, what if cosecant of alpha is now 7/5, right? They just throw a new fraction at you and change nothing else, right? You've seen this before. You guys are seniors. I know you've had this happen to you before, where you start a problem, and then it's like parts A, B, and C are just like different versions of the exact same process, right? So use that to your advantage. Be like, okay, so if I come up with a general process here, I don't make it particular to alpha, right? If your solution depends on alpha equaling exactly 25 degrees, and then you get to part B and it says, well, now do it for 30 degrees, and you're like, oh, shoot, right? Should have given just the general solution, because then I could just plug in the new number and get straight there, right? So with that in mind, we're not going to try to determine alpha. We're going to leave it general. Say for whatever alpha is, just based on the cosecant they give us. We'll figure this one out, okay? So my work backwards is going to be, well, I know I need alpha over 2. So let's look at those half angle formulas to determine then specifically what do I need to fulfill that. Half angle formulas, sine, cosine, and tangent. Where were they? Because I haven't memorized them. Half angle formulas. I want, sine of alpha over 2. Okay, so I'm going to need this. I'm going to need square root of 1 over 2. Okay, that's not a problem. What I need then, relating back to alpha, is the cosine of alpha. So in my think backwards method, just from knowing what I'm looking for, I now know that, in order to get this, I need first cosine of alpha. In order to get cosine of half alpha, I need cosine of alpha. Man, this cosine of alpha seems really important. In order to get tangent of half alpha, I need cosine of alpha again, and I can use just cosine and cosine, or a combination of cosine and sine. You know what? Since I need all three of these, I'm going to look for the least amount of work, right? Mathematicians are always as lazy as possible. I'm going to use, since I have options, I want this equation for tan of half alpha because it only uses cosine. And then all I need to actually figure out is the cosine of alpha. From knowing the cosecant. Ooh, that was so close, right? Can we now see, like, connect the dots here? Back to our problem here. My half-angle formulas are telling me, right? I'm taking this route. They're telling me I need cosine of alpha. If only I was given secant of alpha, that goes straight to cosine of alpha, right? That would be the easy mode of the question. You're hoping, hey, question B, please give me what if secant of alpha equals this? Find all this stuff, right? It'd be beautiful. It'd be so fast and done. No, we don't have that. Okay. I need cosine of alpha. Well, what is cosine of alpha equal to? Right triangle trig. Always default to that, right? So katoa, cosine is adjacent over hypotenuse. I just need the adjacent and the hypotenuse side, right? Hey, looky here, right? At this point, I will figure out, okay, I'm going to need to draw my triangle and figure out that missing side. That's what we had done from the start. They've linked up now, okay? So in a way, this work backwards is a little bit more efficient. If I had gone forwards and just find, hey, take what you know, find everything else possible, I would have done a whole lot of extra work finding all 6 of these. Not necessary. Only need the adjacent and the hypotenuse. So let's merge that together now. The adjacent side is 7. It is a positive 7. The hypotenuse is a positive 25. That's my cosine alpha. So now let's finish this thing. Sine of alpha over 2 is plus or minus the square root of 1. Ooh, it was something. I've seen it enough times, it's coming to me. 1 minus cosine alpha over 2. Okay, and then what's the other one? Cosine is 1 plus cosine alpha over 2. Okay, that's good. They're related. 1 minus cosine of alpha over 2. Did you notice how I almost didn't need to look that up again? Just from having looked at it a few times? And full disclosure, I've literally not done any other work between classes. Okay, I have not been doing extra practice problems to better prepare myself. Like, no, I'm doing this raw, live, okay? Just from looking at them from Monday, I did, 3 problems with you guys? I did 3 questions, and then this one here. Okay, so I've looked at this, this equation a total of 4 times, and it's already starting to sink in. And I can quickly recall it and be like, ooh, it was this version, okay? The more you work with it, the more practice, your brain just develops these shortcuts naturally. It's great. Okay, so this guy is going to be plus or minus square root of 1 minus 7/25 over 2. Yeah? 1 minus 7/25. Well, 1 is automatically going to be 25/25. So what's 25 minus 7? (25 minus 7). 25 minus 5 is 20. Minus 2 more to get 7 down to 18. So we're down to 18 over 25 all over 2, right? Which instead is 18 over 25, right? Multiplied by the reciprocal, so times 1/2. So that reduces with that, we get 9. So this is plus or minus the square root. Oh my gosh, guys, it actually squares. 9 over 25. Were you expecting that? Did anybody actually expect that would just work out? We get perfect squares. I'll be honest, I kind of wasn't. I wasn't really thinking that far ahead, but that's really convenient. Look at this. This is plus or minus square root of 9 is 3 of 25 is 5. Plus or minus 3/5. Is it plus or is it minus? Which one is it supposed to be? How do we find out? Secret formula cheat sheet. Did you tell me? You didn't. Secret formula cheat sheet. And remember the correct sign when numerator. Remember sinus minus. The sign is minus. Sinus minus. I like that. That's good. That doesn't help me here. That's about which sign goes in the formula. Do I use the plus or do I use the minus? If it was of alpha, I know where alpha is, right? I know alpha is in quadrant 4, but this is a lie. This is not actually alpha. This is 360 minus alpha. The real alpha, right? Standard position of an angle is going around this way. This is the real alpha, right? So half of alpha is something like that, maybe, but that's not even right. We already determined that, wait a minute, alpha was supposed to be like this if my 7 and 24 was more to scale. So half alpha could end up in quadrant 2. I'm not really sure yet. Right? Do we agree on that? Like, it's not immediately obvious which one it is actually supposed to be. Is it plus or is it minus? We need more information. So let's hunt through our notes. The original half-angle formula indicates that you must determine the sign of the trigonometric function plus or minus based on the quadrant in which the half-angle alpha over 2 lies. How are we going to determine that? We know the exact value. We can use the half-angle formula. That. How did they figure this out? Because they already know the number, right? We might have to actually figure out the number. Isn't that going to make a difference? Will it make a difference? It only makes a difference if it makes a difference. Where is sign positive and negative? Maybe we can cheat. Maybe we can get away with it. It's like, it's always going to be positive, no matter where it lands, 2 or 3. Have you heard this mnemonic before? All students take calculus. which ones are positive, which ones are negative, right? This says that all the trig functions are positive. In this quadrant, sine is positive. In quadrant 3, only the tangent is positive. And in quadrant 4, the cosine is positive. So sine being the y value, it does depend on where it is above or below the y-axis. So we truly need to figure that one out. Any ideas? I'm going to have to do the same thing for the cosine and the tangent. I need to know where half alpha lands so I can determine its sign. What are we going to do about that? This is the critical part, right? We can't skip this. No ideas? There is one way, the way that we eliminate, right? We determine alpha, and then we get an actual value for half of alpha. And then we find out for sure, hey, is this in quadrant 2 or is it in quadrant 3? I think that's our best bet. Okay? Let's look at some of the other examples here. Do they tell power reducing formulas? 3 forms of the double angle formula. That's the double. We wanted the half. So here's the half angle formula. There's find the exact value of that. Verify the identity. Verify an identity. Man, book, you didn't give me another good example to look at. I gotta do it the hard way. I guess we're doing it the hard way, right? Maybe a shortcut will present itself. Let's hope so. All right. What do you want to use, degrees or radians? Doesn't really matter. Because at this point, I know this guy. I know the cosine of alpha is 7 over 25. So what we're going to do over here, we're going to take a little sidebar. Right? Cosine of alpha. It's not actually alpha. It's not the real alpha. It's the 360 minus alpha that is 7 over 25. Okay? So I'm going to take the inverse cosine of 7 over 25 to equal 360 minus alpha, right? And then alpha will be 360 minus that number. With me so far? And then I'll have an actual degree measure, and then I can divide it by 2, and then I can check, is alpha over 2 greater than or less than 180 degrees? That's all I need to know. That's all I really care about. Which quadrant does it land in? It's as accurate as I need to get. Okay, inverse cosine of 7 over 25. Calculator. No, just the regular calculator I think will work. All clear. 7 divided by 25 is 0.28. And we need inverse cosine of that. 73.74 degrees. Let's go 2 decimal places. 73.74 degrees. Awesome, write that down. This is 360 minus. And so 360 minus that. No, not the at 360. minus 0.4. 286.26. That's our alpha, 286 divided by 2, 143. Okay, so alpha is approximately 286, which means alpha over 2 is about 143, which is less than 180. It's in quadrant 2. All right, I don't need to be any more accurate than that, right? If we actually used this value to find these values, we would have some rounding error, and we don't want rounding error. We want to continue with the method we're going, get the exact version. You're not going to get this. You won't get a perfect 3/5. If you put in 286 some degree, or 73.74, because you rounded this at some point. You won't get a perfect 3/5 out of it. But it's in quadrant 2. All students take calculus. So sign is positive there. We've now resolved that. Sign is 3/5. And now real quick, we can finish off the rest of them. Cosine of alpha over 2 is the cosine in quadrant 2 is going to be negative, so this will be a negative. Square root of, in this case, 1 plus 7 over 25 over 2, right? So 25 over 25 plus 7 over 25 equals 25 plus 7 is 32. Half of that is 8/25. No, 16 divided by 4 there. Square root of, and I wrote it down. 16, brain, cooperate please, thank you. Square root of 16 is 4, square root of 25 is 5, so that should be positive 4/5. And the tangent of alpha over 2. Do you want to use the half angle formula? I need all three of these, right? Problem said find sine and cosine and tangent. Tangent is just the sine divided by the cosine. Why am I going to bother with the half angle formula? Go back to your trig basics here. This should be sine divided by cosine. This should be 3/5 divided by 4/5, right? Which is 3/5 times 5 over 4. Should just be 3/4. They were both positive. Whoops. Include your signs in there just in case. Positive over positive should be positive. Right? No, this was negative. I'm sorry. This one was negative. That's negative. See, double check your signs. So that goes there, and this one is negative. There we go. There's our final answer. Whew! All right. I made it look a lot longer than it actually is, okay, because I'm trying to slow down and explain the whole process, what all you can bring together. Bit of practice, that could go a lot faster. Questions there? No. Other questions from your previous homework? All right, then seeing none, I guess I will wrap up the YouTube stream here, and you've got 10 minutes of class. Go ahead and get started on tonight's exercise set, okay?